Okay, welcome to today's lesson, chapter 3, 10.1. I mean, actually, chapter 10, 10.1. This is my first time doing a live media cast. Anyhow, doing so well. Yeah, definitely camera shy. Definitely can't see me. Definitely have that part turned off. But there's only two chunks we're taking a look at in this part. How many of you guys had a chance to look them over at all? Okay, I guess we're all learning together. So in 10.1, we're looking at groups. Yep. And the idea here is talking about group theory. So group theory is the study of how things can change space and time. And so we will be watching a educational video regarding how time and space can be flexed as per the arts and crafts and drama of Hollywood to kind of see, how do we stretch our mind here regarding what is capable, what is possible. When we talk about groups, a group is a collection of fundamentally basic elements, things like numbers, or atoms, or fractals. We had the chance to do some fractal work last time. When we talk about numbers, we can group numbers based on how they interact with each other and how we use them. Atoms, groups of atoms you might see, we list them in the periodic table. Does that finger mean you have a question? No. Just pointing to God. All right. Group theory can be used to describe a number of different systems, and so that's why it's more of a general concept, okay? When we look at mathematical systems, a mathematical system consists of a set of elements and at least one binary option. What does binary option mean? Yeah, so these binary operations, you have to have at least a this or a that kind of situation. Binary operation is a rule that can be performed on two elements of a set, and the result is one single element. So we take two elements and we can turn it into one. 2 plus 3 is 5. 2 times 3 is 6. Blue plus green, or blue plus yellow, if we're talking about paint, is going to be green.
This is my kind of math.
I wonder if there's going to be...
This is synthesis in chemistry.
Yes, perfect. So we've seen some of these things before, and now we're tying it to a mathematical...
When you take two elements and make them one element.
Yes,
And then decompose it.
perfect.
One, you make it
Like carbon monoxide. Carbon and oxygen makes carbon monoxide. Welcome to high school. A closure. Let's continue. To get closure, maybe you've heard of having closure in events. Exactly. A binary operation is performed on any two elements of a set. The result is an element of the set. Then that is a closed set under that given binary operation. What does this mean? The set of whole numbers, 0, 1, 2, 3, 4, 5, etc. Remember what these dots are called?
Ellipses.
It's an ellipses, okay? So here's an example. 2 plus 3 gives you a whole number of 5. Yes, addition is closed. So we have a closed set. Yeah, we did this a little while ago. I know, dig back. Multiplication, 2 times 3 is 6. Again, it's part of a whole numbers set, so it is a closed operation. Subtraction, 2 minus 3 is -1. Is that part of a closed set here? No, subtraction is not closed because the answer is an integer and not a whole number. You guys hanging in there so far?
Yeah.
What about the last one here, our friend division? 2 divided by 3 is 0.6 repeating. Is this or is this not closed? Not closed. It's a rational number, not a whole number. We're looking for whole numbers, people. So we have to make sure we're taking a look at what exact group we're talking about. So as we continue on to our cumulative, words are coming out of my face, commutative and associative property. In the commutative property, if we have A plus B, that's the same as saying B plus A. Same with multiplication. A times B is equivalent to B times A. We can move things around. You can think, I like to think of the word commutative like you're riding on a train or a subway and you're commuting to your workplace and you go back and forth between work and home and work and home. And you do that for 60 years. Anyhow, commutative property allows you to kind of go back and forth with how things are lined up. On the other hand, the associative property, again, we're using parentheses. We're grouping things. If we're using the same series of processes, addition, we can use parentheses to group different features. Same with multiplication. AB times C is the associative property says we can also run that as A times B times C. We look at identity elements. An identity element is an element in a set such that when a binary operation is performed on it and any given element in the set, the result is the given element. What does this mean? We have the additive element of 0. If I have 5 plus 0, what do I get? That didn't work out. That was awkward. Okay, there's another error. No problem. There'll be like a bunch of Easter eggs in this, and maybe you'll get extra credit if you can find all the Easter eggs. Who knows? There it is. 0 plus -3. What does that give us? -3. Okay, so obviously, yeah, that's a problem. A plus 0 is? A. Very good, very good. The multiplicative identity element is 1. Let's go. 5 times 1 is?
Oh, I get what.
Yeah. I know, that's the thing. This right here probably threw you off. Let me fix it immediately. I wonder if I can fix it immediately. Let me fix it immediately. Can I start from here? Oh, I can't.
There's no space.
Oh, let me fix it immediately. Can I run it from here? I can right there. Okay, so yes, look at that. If you go back 12 seconds, it's amazing. 5 plus 0 is 5. 0 plus -3 is -3. A plus 0 is A. So this is the identity element. So we are identifying addition. We can identify a number if it's something you can add to 0 and get the same thing. Yes. Multiplicative identity element is 1. So 5 times 1 is 5. 1 times -3 is -3. A times 1 is A. And we use that to help us identify the numbers we're working with. The next piece, inverse. When a binary operation is performed on 2 elements in a set and the result is the identity element for the binary operation, then each element is said to be the inverse of the other. What does this mean? For addition, we have opposites. If I can get a 0 after the equal sign, that means I've got an inverse. 2 plus -2 is 0. -3 plus 3 is 0. A plus -A is 0. So this is the inverse for groups. In multiplication, we use reciprocals. Whoop, whoop, reciprocals. Yeah, you put it over a 1, you put it under a 1. Let's see what it looks like. 2 times 1/2 will give you 1. -3 times -1/3 will give you 1. And A times 1 over A will give you 1. Those are all examples of inverses. Hopefully some of this is shaken loose in the old mind frame. Let's keep rocking. Properties of a group. Any mathematical system that meets the following 4 requirements is called a group. Number 1, set of operations is closed under a given operation. So that's, if you go back in the video a little bit, you'll see what that means in case you forgot what closed means. Number 2, an identity element exists for the set. We have to be able to identify. Addition is going to be a 0. Multiplication is going to be a 1. Every element in the set has an inverse. So if you have 2 in the set, you can have 1/2 as well as its inverse. And then the set of elements is associative under the given operation. Associative being able to move those things and use the associative property. So our rational numbers are grouped under multiplication. First off, we have to recall a rational number or any number that can be written as a fraction. So what do you think? Is it a group? Is it closed? Is it closed? Yeah. It is closed. Yeah. 1 over 2 times 2 over 3 gives you 1 over 3. This is a rational number. So we have a rational number times a rational number. We get a rational number. Hip hip hooray. Does it have the identity, or can it be used to formulate the identity? Yes, you can. 1/2 times 1 is 1/2. That's the identity property. What about the inverse? Yeah, 1/2 times 2 over 1 is going to give you 1. Both of these are rational numbers. And lastly, associative. Can you use the associative property to move around? Absolutely. 1/2 times 1/3 times 1/4 is 1/24. Well, guess what? 1/3 times 1/4, and you take that times 1/2, you get 1/24. Yes, this is a group. So the rational numbers are a group. We've just proven that. Put that in the data banks, make it stick. What about irrational numbers? Are irrational numbers a group? Recall that irrational numbers are any number that cannot be written as a fraction. So first question is it closed? It is not. It is not. Irrational numbers, yep, square root or rational 2 times rational 2 is 2, which is a rational number, not irrational. So if you got a irrational number here, then it would have been okie dokie. Okay, nope, they're not going to group under multiplication. Questions on this? That's the last slide I have, or VDB had. Can I go back slide? Absolutely. Has to be closed. Has to have an identity. has to be inverse, has to be associative. In fact, I can go back another set of slides. And we'll end on this one right here. There you go. Properties of a group. GG, everybody. Thanks for playing along. GG. We'll see you in the next one. Good luck.